Hey, thank you for the introduction, Jim. My name is Moritz. Next to me is Fabio, our VP of Engineering. And today we would like to share the learnings that we've had over the past 4 years building Hopsworks Feature Store, and also share a little bit what's next, what's after this. So let's take a step back and look at the problem that the Feature Store is trying to solve and recap a little bit before we dive in. Looking at how machine learning applications are deployed within enterprises, and also what kind of or how they generate value for the business. The first step is usually this kind of what we call laptop ML or artisanal ML, which means basically someone in the business is using a machine learning model to do, for example, a predictive forecast of sales or cluster the customer base in order to get a better understanding of the business. But the higher value business use cases are actually the ones where you have to take your machine learning model and operationalize it. That means either users are directly interacting with the machine learning model through your product, you so-called operational ML models where you do inference at real time, or more in a batch analytical fashion where you create batches or compute batches of scores every night or every week, and then use those in your product or in customer communication to improve the business. So what is actually the data problem, and where is the Feature Store trying to help? And that's actually jumping from that artisanal ML to the operational trajectory, right? And that's often called the data problem. Over the past 4 years, we actually saw, and when we talk to customers and other companies trying to build feature stores, that it actually splits up into 2 challenges. One is the data write challenge, or how we call it, and the other one is the data access challenge. With data write challenge, we mean writing the data into a centralized storage where it's available to those use cases. And oftentimes those use cases have different requirements than, let's say, a traditional data warehouse can give you. So for example, for operational ML, you want very low latency on feature vector lookups, which a normal data warehouse usually can't give you. And then the other challenge is actually that we discovered is the data access, which means once you have all the data in a centralized storage and you're able to reuse it, you also need to be able to make it available to especially data scientists in an easy way, so that they can train their models and develop those ML applications in the first place. So when starting to build the Feature Store, the first tool that comes to mind is Spark. And that's also how we started, because it's a multi-storage engine, it's scalable, so it has a lot of the properties that we're looking for in order to write data into the Feature Store. So when we started out with Hopsworks 4 years ago, we were mostly aiming to tackle the problems of the pain points of data engineers. So reading data from different storages, performing feature engineering in a scalable fashion, and writing the engineered features back into the Feature Store to make them later on available to data scientists. And then around that, we built a lot of functionality, such as orchestration or integrating with orchestration, Airflow, providing support for different languages, so Python, but also when you use Spark, you might want to use Java or Scala. Like I said, different storage connectors, adding statistics to make the data more descriptive for the data scientists later on, but also tracking lineage. And then later on, you also want to add online storage, which is the low latency storage that gives you access to the features for real-time serving. And with that, we also worked on a writing pipeline to the online Feature Store for streaming applications. And then throughout the last year, actually, when we got closer to the data scientists, we realized that data scientists still want to use Python, right? And Spark might be overkill, especially when you want functionalities like point-in-time joins. You might want to have the scalability of Spark, but you don't want to put the burden of writing complex SQL queries on the data scientists. So the challenge we faced in the last year, or the effort we made in the last year, was providing Pythonic or Python-first APIs to this functionality with the scalability of Spark. And then with that, since we focused more on Python, we were also able to integrate tools like Great Expectations that come more from the Python world to provide, for example, data validation, but also adding pure Python transformation functions, which actually lead to reusability of features. And then if we look into the future, so now that we have the data challenge or the data problem under control, the next step will be actually writing prediction services and also closing the loop. So tunneling back predictions and feature values from the prediction service back into the feature store to allow analysis on that, or to further improve the models and provide this machine learning flywheel that we often hear. How does this look like in Hopsworks in terms of abstractions? So in the first effort, as I said, we wanted to make also feature engineering pipelines more accessible to the data scientists, because what we saw is that also data scientists want to go in and maybe make small variations of features and be quick in publishing those features to the feature store. And for that, we took our write API, which is essentially the concept of feature groups. So you write to feature groups, and we made that also a Pythonic experience so that data scientists can easily go in, modify features, but also interpret features better. And then the other side in the last year is the feature view that was added, and that is basically the API to consume features from the feature store in a completely Pythonic fashion. That includes transformation functions like normalizations and one-hot encodings, but also getting training data in certain file formats in case you want to use a different, in case you want to use a training framework that requires, for example, TF records or NumPy files. And then also point-in-time joins, making those accessible through a Pythonic API. So yeah, and then to dive deeper into how this looks like in Hopsworks, Fabio will take over.
Okay, thanks, Moritz. So let's have a deeper look on how we actually solve the data write challenges and the data access challenge from a code perspective, right? So back at the beginning, we made a really strict decision of actually going for data frames API and not actually implementing a DSL. There were a set of reasons to why we choose that path. Essentially, the first one is flexibility. We wanted Hopsworks to be able to address a wide range of use cases, from NLP use cases to anomaly detection, forecasting, and so on and so forth. And that requires slightly variation of different data engineering practices and so on and so forth. And that's basically allowing us to have a better approach using data frame API and the wider range of libraries that are already out there. The second one is user experience. We didn't want to actually having users having to learn an additional DSL that is only applicable to Hopsworks. We wanted that to bring their own knowledge of how to work with Pandas data frame or Spark data frames and be able to actually apply it in Hopsworks directly without having to learn new tools and new frameworks and so on. And finally, it was a practical approach to basically say a lot of our customers and users already have existing pipelines. So we don't want them to, when they want to adopt Hopsworks, we don't want them to go and having to rewrite those pipelines. We want to be able to pick them up and just plug them into Hopsworks and off they go. There's another details, like practical details of why the Python as a first-class citizen in Hopsworks 3.0 and why Spark is not suitable for data scientists. But we saw working all these years with data scientists that there are certain challenges when using Spark. One of which is actually resource estimation, and Spark has a lot of knobs to tune, and it's really easy for you to blow up your Spark application if you don't really know what you're doing, or if you're trying different things. The second one is debugging. Spark has a lazy execution model. You assemble a bunch of operations, and then Spark does a bunch of stuff, and you have don't have much visibility into the existing thing. Not as much as, for instance, pandas, where you're basically doing interactive changes and so on. And then there's a practical things that, like, the tools don't match, essentially, right? So all the tool for training models, serving models, are all Python centric. You don't have a Spark context available, so it's really hard to work with this thing. So that's why we invested a lot of time and effort into the bringing like a Python centric experience. How does it look like? If you see here, for instance, we have first set, we have a like a plain pandas data frame manipulation. We're doing some Windows aggregation here. Whether this is a new code that you're writing or existing code that you already have, you just plug it in, call the get and create feature group. You attach a bunch of metadata, whether it's a name, description, version, primary keys, if you have event time, and so on and so forth. And then at the end, you basically say, I can write this thing to the feature store, and the feature store takes over and writes it to the online, offline feature store, depending on what you need and what's your use case. What, like as Maurice was mentioning earlier, right? When you adopt a Python-centric like a API, then you can easily integrate with the wider range of libraries that are already existing. One of which is Great Expectation, right? So we added support for Great Expectation, and we actually do it before we write. Like, the Great Expectation is necessarily executed before you actually write it to the feature store. What that actually enables that all the data that you are sure that all the data that lands in the feature store is actually clean and respects your validation, right? And like, there is nothing, the way you use it essentially is in the pure Great Expectation side. You define the expectation suite, you attach the expectation suite to a feature group, and before every time you insert the data, the expectation is validated, and then Hopsworks does a bunch of like metadata management. For instance, there tracks which expectations we attach, when they've been run, whether or not they've been successful, and whether or not you have actually ingested data to the feature store. On the other side, so that was the data write problem. So how do we actually enable data scientists to actually use data and build prediction services, and then deliver prediction services? So we introduced a new concept in Hopsworks 3.0. Which is the feature views, right? So it's a Python-centric API to be able to access, and I'm going to show you in a second, access features, and I'm going to show you in a second how you can work with that. It's Python-centric. There are a bunch of different reasons for that. First of all, as Maurice was mentioning at the beginning, all the ecosystem from training model and serving model is all Python-based. So we need to have a way for data scientists to actually stay in Python and access all this feature data that is available in the feature store. The second aspect is that we want to make sure that we integrate with those, like the TensorFlow, PyTorch, and all the rest of the ecosystem, by allowing you both to return, both to access the feature data as pandas, but also as files, and then also as files specifically in the file formats that are required. Whether it's specifically, like, for instance, if you use TensorFlow, then you might want to access data in TF records. There are a bunch of other additional functionalities that we added. One is, as Maurice was mentioning earlier, point-in-time joins. So if you're using features from a bunch of different feature groups, and you're using you're reusing those features, oftentimes those features are written with different resolution, which makes, when you're joining them together, you have to make sure that you're joining them in such a way that you're not leaking data from the future, essentially. And that's a complex problem to tackle. That's a complex SQL query to write. So from Hopsworks perspective, we provide user like a pandas-like API to access those features. And I'll show you in a second the example and be able to actually retrieve that. And finally, one additional point is transformation functions. As Maurice was mentioning, transformation functions for us is everything that happens after the data is written in the feature store. And that's often for instance, normalization, imputing missing values, or for instance, one-hot encoding, and so on and so forth. All this happen after the feature store, so at the retrieval point, to allow features to be reused across different models in a different subset of feature data, and so on and so forth. And finally, I was mentioning earlier, Spark is oftentimes not present in training model, but also not serving. So we don't have a Spark context available. We cannot rely on Spark. And so we need to provide a Python-centric API. So how does this actually looks like? If you're looking at a code perspective, we retrieve feature data from the feature store. We retrieve the metadata objects for the different feature groups that we want to deal with. That's the first couple of lines. We assemble in the query object to actually query the data on the feature store. We do that with this pandas like API, and behind the scene, Hopsworks is going to transform this in a point-in-time correct join, and it's going to execute that on behalf of the user. And finally, the last step is basically creating the feature view object and registering the metadata with Hopsworks. And here you just give it a name, like the query that you want to use. If you want to have the labels that you're gonna use to predict, and if you have transformation functions, which transformation functions you want to apply. Hopsworks comes with a set of transformation functions, but we also are flexible and support like user-defined ones. And then the feature view is actually registered. What feature view actually gives you access as data scientist, actually, it's what we call one API to rule them all. It gives you access to both trained data. So for instance, from a feature view, you can generate a trained data set. You can either, you can specify the file format. So as mentioned before, if you're running TensorFlow, you want to get in TF records, you can split it up in different ways and actually generate that static file set that you can then use to train your model. You can also get back a trained data set as a pandas data frame. So you can just use it directly to actually train a specific model. You can, after you've trained the model, you can use the same feature view to do either batch predictions or real-time predictions. So if you're doing batch prediction, you can specify, for instance, a time window. So you train a model for the first, 11 months of the year, and then you want to be able to make a batch prediction for the last month of the year. So you can basically specify, time intervals for which to retrieve data from the feature store to be able to actually do a prediction. And the last part is actually the real-time lookup. So like powering what we call like prediction services, allowing you to actually build a real-time application to actually make those predictions. And the way it works actually, from our perspective, like Hopsworks is integrated very well with KServe, but it actually gets integrated with any other serving framework that you have available, even if you have built your own. That's pretty trivial to actually do. To integrate Hopsworks with, and essentially what happens is that you make a REST call to KServe on the Hopsworks case, and the KServe is going to run this predict method. There's actually two parts of here. The first part, we're actually setting up the prediction service. So you're basically just loading the model, but also loading the feature view that we actually need to use to retrieve that information. And then if you see from line 25, we're actually doing the prediction here. We're going to the feature store. We provide, in this case, we're doing fraud detection of credit card transactions. So we're providing, we want to look up the credit card feature data, and we want to be able to retrieve that. And so this is going to go to the online feature store. It knows, the feature view knows all the features that are needed, retrieves them, and it passes to the model to actually make the prediction. And finally, there's a small plug. If you want to try it out, Hopsworks, you can just go on up to Hopsworks.ai. It's our serverless offering. You can just register for free, and you get access to a fully fledged Hopsworks platform to be able to build your own prediction services. There is a course going on that Jim is running that you can actually subscribe and learn all about serverless ML essentially. That's everything.
Thanks, Fabio. Thanks, Marth. That's great. So we have a couple of questions. We have a little bit of time for the questions. So we have Sai Girish asked the first question. This is Great Expectations used before pushing the data into the feature store or after pushing the data into the feature store?
Yeah, I can take it. So that's what Fabio was explaining, that actually we want to avoid bad data gets into the feature store. So That's exactly why we run it before it's being written into the feature store. So there's a bunch of policies you can specify. So either you can say, ingest the data no matter what happens, and you just get a validation report, and then you can trace back later and look what was wrong with that batch of data. Or you say reject everything as soon as one of the expectations fails. And then when you get back that result in the API, you could take your data frame and dump it somewhere else into a temporary feature group or into some temporary storage, so that you can later on take a look at it again and see what went wrong. Our approach is here that we want to avoid those garbage in, garbage out situations, because basically once bad data is in the feature store, what is your data scientist going to do when he tries to build a model, right? He wants to get a feature and then create expectations. It's going to tell him the quality of the feature is not good or not enough. What is he going to do, right? He cannot kick in the whole kick off the whole feature engineering pipeline again. So the goal is avoid it.
We'll take one more question, and then we'll have to take the other ones on Slack. Actually, there's two interesting ones. If you can answer the first one quickly, then we can get the second one. So the first one is, how difficult is it to convert your programs from pure Python into Spark? That's by someone who's anonymous.
I mean, it really depends what you're doing, and it really depends on the knowledge of your Spark knowledge. That's not like from our perspective, from Hopsworks perspective, it doesn't really matter how you write your program. At the end of the day, you just have to provide the data frame, and it's the same API if you're providing a Spark data frame or a Pandas data frame, and we take care of that from that perspective.
And then one last quick one, again, has to be quick. Transformations after feature retrieval, does that increase latency? Why would I do it if it increases latency? To increase
reusability. It depends on your writing. It depends what your obviously what the latency requirements are. But if you are segmenting your feature data into different subsets, or you might have a model looking at the past 5 years of data, you might have a model looking at the past 10 years of data. If you are normalizing those two models, like you're normalizing features for those two models, you can't reuse the same normalization. So that's why we do it after, when you're actually retrieving the data from the feature store. And so when it's like real time, we already have pre-computed all statistics. We're not going to go and compute it every time. So we just have it's just a matter of applying those statistics directly to the data coming in.
Okay, thanks. I think actually Amit mentioned it already. You called them model-specific transformations. I like that term. I'm actually using it in the course, in the Feature Store Service ML course. There's a lecture on it today where I talked about model-specific transformations. So transformations after the feature groups. Okay, that's it. Thanks, guys. It's been brilliant.